Due to technical difficulties, we are joining the program already in progress.
Let's see how smartphones are pervasive in our all-day life. So, how did you arrive here? So, let me have a guess. Somebody arrived by flight, so they took a plane, and in order to get to the plane, they have to check in online with their own app on their own smartphone. And you are able to check in online, you are able to download your boarding pass, so you don't need to print it out anymore. But maybe you came here by train, and even for the train you have an app which tells you about the schedule of the train or any other news related to this means of transport. And if you came here by bus, there are bus companies that provide an application for you and tell you where the bus is right now, and maybe if you are going to catch it or not. Or riding a cab, you don't have to call the cab anymore. You just need to book it via the application, and you can see where is the driver and when he's going to pick you up. Or you came here by car, and even with a car, you have some application that tells you how something about the traffic, and if there are some speed checker. Maybe you live nearby here and you came by foot, and no app for that, sorry. So you have to wear on your boots. You have to use the old-fashioned paper map, but just kidding. There is an app even for that, Google Map and City Map. So these are not pervasive enough? Think about what you do. What did you do while you were traveling? You may post some content on Facebook. You may read some news from your favorite newspaper. You may have listened to the music, watch a video, but not only that. You may have a phone with a call with your friend, check the calendar, have a selfie. Basically, you can do an infinite amount of actions with your phone. But then this is not enough. Since smartphone became more and more powerful, you are able to watch some video via streaming, and even streaming your own life via Snapchat. And these kind of apps are able to drain your battery in a matter of hours because of the high energy consumption. But not only that, you even have porting of consoles game on your phone, and even augmented reality games like Pokemon Go. And as a personal experience, you will not be able to last one day play that kind of game with your battery. You need to recharge. So, because smartphones are pervasive and that they let you connect with all the world, there are some people that really suffer if they don't have their own phone with them. And there are some studies that showed how people is able to take a look at their own phone for more than 80 times per day. So this is a sort of addiction. And try to guess if some of this kind of person didn't recharge their phone during the night. What happened the day after when they are running out of battery and they are not able to recharge it? That's panic, right? So let's think about our priorities. What was about 2 years ago, or even 5 years ago? We were constantly looking for a place to connect to the internet with our phone. So we were going to Starbucks and on some other place with free Wi-Fi in order to get connected. But now it's not like this anymore, because there are free internet hotspot, but also the mobile carrier companies. They provide you with subscriptions that are quite good. They offer you a gigabyte of internet traffic for a fair price. So right now, the priority is not to find somewhere to connect, but is to find somewhere to recharge the battery of your phone, right? And when there is this kind of demand, the market responds. And how the market responds? You are able to see some device like this, even here, at the entrance of this conference facility, but also in the gyms, in malls, train station, airport. You are able to go there, you put your phone there, you plug in the cable, you leave the phone there, and you go out, and while the phone recharges. But not only this, maybe in your hotel room, you are able to find a USB port attached to the old-fashioned power socket. And this can be found even in the airport, but also on the buses now and trains. But if this is not enough, you have the power banks. And think about it, is a bigger battery to recharge your battery. Okay, it's quite funny. And in China, you can rent your own power bank. There are this kind of device here that are very popular in gyms. You go there, you scan a QR code, you pay an amount of money, you get your power bank, and when you finish to use it, you put it back. So now we have places to recharge our own phone. But then, this is interesting for hackers. And what we witnessed in recent years are many attacks that exfiltrate information from your phone. They install malware on your phone while you are recharging it because of something unprotected. You have just your cable, you plug in, but you don't know anything about the USB port that you are using. And these attacks are popular for Android, iPhone, and Windows Phone. But, and go on and go on. And particularly, this attack is quite interesting since when you connect your phone, it turns the USB cable, thanks to a functionality of the phone, it turns the USB cable into a VGA cable. So when you plug your phone, the attacker is able to see exactly what you are doing with your phone. And this kind of attack is called Juice filming attack. So, what is in common among these attacks is that they use the data transfer connection. So, this is a zoom of a USB port, okay? We have 4 pins. 2 pins are used for the power, to give power to your device. And 2 other pins are used for the data, for the serial connection. So, some countermeasures that are in place now uses, this is a software countermeasure, for example, by Android. So when you plug your phone to a USB port, you are not transmitting data by default, but you are in a charge-only mode. So hopefully your data will not be transferred. But if this is not enough for you to be quite sure about your data to not get exfiltrated, you even have these kind of devices that they cut off 2 pins and only allowing the power pin. And this device can be found on Amazon, and there are the cable one and also the dongle one, for example, this one. And do you know how they called it? They are called USB condoms because they prevent you from not wanted infections. Okay, so after all these countermeasures, there is also another one, which is using your own power bank, okay? So hopefully you will not get your data exfiltrated. But this is enough? So no, because instead I would not be here, right? And but before to entering the core of this kind of attack, we need some background knowledge about how the smartphone recharges a battery, okay? So from this plot, you can see the charge capacity of the battery in the right y-axis. And as you can see, the battery recharges over time and then start increasing with a higher rate at the beginning, and then still increasing, but with a lower rate. Let's see what happened to the voltage of our battery. Start to increase very fast, very rapidly now, but then less rapidly until it gets constant for the for the rest of the charging. But what is interesting here is the current. So this is the maximum current that the power supply is able to provide. And at the beginning, the battery has absorbed all the power that is provided. But after some time, precisely when the voltage starts to become constant, it starts to drop down slowly till you reach at zero, okay? But still, the power supply is still be able to give you this amount of battery of power, but it's not used because the battery works in that way. So if this amount goes to the battery, what about the rest? Maybe can be used by the smartphone in order to work while the battery is charging. So in order to verify this, we have to do a little bit of experiment, right? So we have our smartphone here with a low battery, and then we connect the smartphone through this kind of device. This kind of device is called Monsoon Power Meter, and is able to measure the current that is provided to a smartphone. Then this is the output port, but this is the input port that is connected to a power source that can be our USB adapter. And this kind of tool is able to measure all the current that is flowing through this, which is a sort of bridge. So, first experiment. As expected, with a low battery, we have a constant current. So, all the current provided by the power supply goes directly to the smartphone battery, okay? But then, when the battery charge starts to raise, reaching the 50%, we don't have anymore the current here, but it's going down. And now we can see a little bit of noise, right? Let's investigate more. We know that the display consumes a lot of battery, right? And especially the brightness. But let's try to do an experiment. So let's turn the display on and off, and let's see what happens. As we can see, when the display is off, we have this level of energy consumption in terms of current. But when I turn on the display, I can see a peak. And then when I turn the display off again, I see the original amount of current provided. We are almost there. So what about CPU bursts? When a CPU works in an intense fashion. So let's write our own application, very simple application. We declare the duration of a burst, which is 1 second, and then we let everything into a while loop, and at the beginning, the CPU will sleep. But then, the CPU is forced to increase a dummy counter for the whole duration of the burst, thanks to another while loop. And when there is the timestamp for the burst to end, the burst will end. And what happened? Here is the result. We are able to see that when the CPU is idle, we have no burst, and we have flat current. Sorry. And when we have the CPU burst, we have an increasing of energy consumption, and thus current absorbed. So at this point, did you have my same idea? How can we use this? So imagine that we have to transmit a string, classic binary code. 0 for a burst and nothing for 1. And then we modify our simple code in order to do that. So if we have a 0, we do the same as before. If we have a 1, we just let the CPU sleep. And this is what we have. And we are able to recognize when there is a burst and where there is not. So we are able to decode it and get off the binary information. So did you just see what we did? We start with a smartphone, and we turn our smartphone into this. And for those of you that are too young to know, maybe all of us, is a telegraph. Okay, line, dots, line, dot. But this works with the CPU burst. So let's talk about this kind of covert channel. What we're able to control and what we are not able to control. Because think about it, this was not meant to be there for us to use. So right now, we are not able to control the intensity of a burst. We just know the burst and not. So we cannot control the energy consumption amplitude. But what we can control is the timing, but not very precisely, since this channel is not very reactive. Every time that I start a burst, it takes a little while in order to reach the top. And then, when I stop the burst, it takes a little while to go down again. That's why we cannot push it too far in terms of data transfer rate. But let's see what we can do now. Let me present you Bob. Bob has a secret on his smartphone. For example, a file with all his password or bank accounts, or maybe the number of Donald Trump in his contact list. And he doesn't want to share with everybody. So Bob is quite paranoid, and he doesn't allow any application to access to the internet, just in case to not get his secret stolen. And then, when he installs an app, he always double-checks the permission that that app requires. And then, since he has a smartphone and the battery may run low, he always brings with himself a USB condom. And when he charges his phone, he always uses a USB condom because he knows about the privacy and security risk of public charging station. So Bob cares about his privacy. So everybody be like Bob. But at the other side of the cable, there is Mark. And Mark knows that Bob has a secret. And he wants to know that secret. And somehow, Mark was able to install an application inside Bob's phone. But Mark knows that he cannot rely on the internet because of Bob's paranoid. So, but Mark is really motivated to exfiltrate that kind of information. So how can Mark do this kind of attack? This is an attack scenario. There is Bob with his phone, and we have our PowerSnitch app, which we will talk about later in detail. And the app takes as an input the password and is ready to transmit with the covert channel that I showed you before. And Bob wants to recharge his phone, connect his phone to the power supply, which is controlled by Mark. And just to be sure, just turn all the Wi-Fi capabilities off with the flight mode or just switching them off and using a USB condom. Then Bob, since the smartphone is going to take a while to recharge, he just go away and having a nap or just some shopping. And in the meanwhile, thanks to our covert channel, the information is exfiltrated to and the energy consumption can be measured at the other side of the cable. And from the measurement, we can decode the information back and give it to Mark. So let's check our application. Our application takes the information, it encodes the information, serializing it, so 0, 1, 0, 1, etc. And if we want some more robust transmission, we can also add a CRC or error correction code, name it. And then we wait for the cable to be connected, because instead, no cable, no transmission, right? And when it's connected, and there are the ideal the ideal condition to transmit, it just keeps generating bursts according to the encoded payload. How this application works and what this application requires. So this is our prototype. We just input the payload here. We can encode a string that we just input using an ASCII code, okay? And then we can start and stop the transmission. And when the transmission starts to go out, we can say also the data rate transfer. What is interesting is that this application only needs two kinds of permission, okay? Actually, it needs the permission to access the information we want to exfiltrate, because instead we will not be able to get it, right? But plus, only require two permissions, which are not considered dangerous for the privacy, which is the wakelock permission and the battery manager permission, just to know when the cable is connected or not. And the wakelock permission in order to wake up the phone while it is in the standby. And of course, it doesn't use internet access. How the decoder works? So since we can see our energy consumption as a signal, we can apply signal processing using new radio. And let me go through step by step of the decoder. Let's start with the first one. And no, I'm kidding, too long. So this is our signal, which is an actual signal from a real phone. And we have a synchronization preamble in order to let the power supply know the timing of each bit. And then we have a not return to zero encoding, which is quite robust. And we can see the burst and the not burst. But first, thanks to this preamble, we are able to divide the transmission by the bits. And then we are able to recognize whether a bit is a 0 or a 1. And after that, we can divide it to bytes, since we use an ASCII code, and then blackhat. And we are able to get our message back. Okay, this application is not very smart right now, right? It just transmits no matter the condition, so it's just like a blind ramble and very noisy, and it can be detected, right? So let's be smart, and let's be more precise and more silent. So as I told you before, we don't need no special permission, but the one to access the data we want to exfiltrate, no internet permission, and even if some battery saving method is in place, the battery saving method doesn't work when the battery recharges, because there is no battery to save. And then even those mode on Android is not affecting our method, which is good. And then how our application can be deployed. Maybe could be some apparently innocuous application, for example, a fancy alarm clock that can wake you up with your own music. But to access the music, it has to access to your files, right? Or can be a popular package app for third-party markets. But then you may wonder, okay, the display consumes a lot of energy, so why did they use the display? But come on. If we want to let the display consume, we have to turn it off. And the victim will notice his phone flashing. So it's better to use the CPU bursts, which are not easily to be detected. But we have to be careful because they can still be detected. How? We must have the screen off so the user cannot experience some degradation of the user experience because of CPU is running in the background, right? And then Android Debug Bridge is able to let you monitor the resources of your phone. So if you have the Android Debug Bridge active, you can see the CPU burst, and we don't want to let the victim know about it. So when the ADB is active, we just keep silent, right? And then, because of the initial constant current, we are not able to transmit because we are not able to observe the CPU burst. So we have to wait smartly until the battery is above a certain level of charge. But of course, I don't want our application to transmit every time the phone is connected, because if nobody is listening, there is no way, there's no mean for the transmission. But the power supply can let the application know whether he is listening or not. And using the battery manager permission, you can, the power supply can vary the current in order to get charging, to charging slowly, to charging again with a precise time. And so the application will know that somebody is listening because the power supply and the battery pre-agree on this kind of communication. And then, since we are using only the surplus of the current provided, this kind of attack doesn't affect your battery recharging. But then, at this point, okay, Mark is motivated, but not that motivated, right? And this tool is an excellent tool, but it's quite costly. So no matter how Mark is motivated and rich, he's not willing to deploy for each cable power monitor. So how to make Mark happy? We want this device to measure the energy consumption to be cheaper, smaller, and easy to be deployed. And how? Electronic by ourselves. So we have to take a PCB board, and something we want is that all this circuit here has to work with the normal energy that is provided to a smartphone, which is 5 volt here. And then we want to measure the current. So we have the power supply cable coming here, and then the smartphone cable side. So from here, acting like a bridge, we are able to measure the electric current. How? With this kind of sensor, which is a Hall effect sensor that takes the current as an input and then gives the measurement in output to be read by an Arduino, a simple Arduino that keeps sampling the information, the current, and then it can transmit it outside. Okay, and if a Wi-Fi network is not available, you can use a GSM module. And if none of them is available, you can simply store the information for later to be transmitted to Mark. And the size of this is this. Oh. But I'm pretty sure that can be even smaller, maybe with someone that is more practiced than me. So, you see, we reduce the dimension and we can place it inside here, especially if the manufacturer is willing to exfiltrate information. We can deploy in power port in the wall socket and even on the power adapters. Okay, so Mark is happy. Let's see how happy is he. I can find all the components on Amazon. And even if this sensor is quite good and very precise, my grandma doesn't allow me to spend a lot of money. So I have to go cheaper. And these kind of sensors are cheaper than the other one, but still are able to measure the same amount of current. So we are happy about it. And then let's get an Arduino in a bundle of 3. Let's get a Wi-Fi module. And even if we are not very lucky and we have to store the information, we can use SD card module in order to store the information, but still the price is quite cheap, £17. which is 40 times less than the original power meter. So Mark is happy. Let's see it work. Video time, video time. Let me put it in full screen. So here is our beautiful app. Oh, that's unfortunate. Okay. This is my colleague using the app. Switch the smartphone off. We have the Arduino connected to the serial cable and the current sensor, which is connected to the power cable, to the power source, which is the laptop now. And then we start the sampling. And as we can see now, we have the first burst. We have another one. We have another one because this is preamble, but let's skip it because let's do quite faster. And then when the signal is no more there, we can apply some new radio magic and analyze what we just collected. But what we collected is in a binary format, still an ASCII code in a binary format. So we have to make it human readable. And as you can see, here is our message. Success. So what we can learn from this talk, first of all, that there is a covert channel, which we use on the Android device, that uses only the energy consumption in order to exfiltrate an information. So even when a USB condom is in place, we are still able to transmit our information outside. And then this attack is low cost and so small that can be deployed easily in power banks, field charging station, or even on your USB adapter. And so far, just for now, one of the ways that I can suggest you in order to not get your information exfiltrated, when you recharge your phone, just turn it off, just in case, okay? Let me have a brief thanks for the people involved to this project, especially Laila Abudahi and Professor Radha Povendran from University of Washington, which helped us with the first version of this attack. Professor Ivan Martinovic from the University of Oxford and Elia Dal Santo from University of Padua that helped us with making our application as a service. And then our universities. University of Padua, the Spritz Research Group, Utrecht University, University of Oxford, and University of Washington. So, thank you very much for your attention. If you have any questions, I'm really happy to answer them. Thank you.
I have a question down here. To have proof of concept on iPhones, and they can't be turned off while recharging. So do you have any recommendations for that?
Excuse me, could you repeat the question, please?
Yeah. Actually, there was two. The first one is to have a proof of concept on iPhones, and what is your recommendations for iPhones since you can't turn them off while recharging? Oh,
so let me repeat the question. Since you cannot turn the iPhone off while recharging, what is the recommendation in order to not get the data exfiltrated? Is it right?
Yes. Yes.
Okay. So far we looked into Android, but and we didn't look into iPhone. So sorry, but I'm not able to answer your question. But we will definitely take a look at it in the future. Thank you.
Hi. Have you considered wireless charging as well?
Yes.
Is the same attack possible or version 2.0?
So the wireless charging, we take a look at that. The channel is very noisy, and probably that will be a good countermeasure to this kind of attack, because the wireless charging, as far as I was able to observe, consume a very high amount of energy and is not very related to the battery. So is all the current is absorbed by the charger and not by the phone directly. So that could be a good countermeasure so far. Thank you.
Hi, I was wondering what the rate of data exfiltration is. Like basically when you're doing a video, it seems like there's quite a long thing. Each spike was actually quite long.
So the question is which data rate we are able to achieve so far. So because of the delay from the idle status to the burst status, we have that kind of delay. We were able to, the highest data rate transmission we had is 2 bits per second, which is quite low, I know, but this kind of cover channel was not meant to be there. So, but let's say you are easily be able to, if you charge the phone overnight, you are usually able to exfiltrate all your contact list. So it takes like, to transmit 500 bytes takes like 10 minutes, something like that. Thank you for the question.
Hi there, just wanted to say great presentation. And
thank you.
Have you tried to work out what smartphone apps are in usage from the power usage?
Could you repeat the question, please?
Have you tried to work out what smartphone apps are being used from the power usage?
That's a good question, and actually is something that we thought about. Okay, for those of you, okay, I will repeat the question. Are we be able to recognize an app from the power consumption? Well, spoiler, we are working on that, but so far, yes, but we are working right now on that. Thank you for the question.
Hello?
Hello?
So have you tried testing that against something that uses more proprietary type of charging, such as dash charging, which actually has constant communication between the phone and the charger, since it's a faster form of, let's say, Qualcomm quick charge or so? Since will this affect the transfer of data, since there's actually communication already happening between the phone and the charger?
Good question. So how about dash charging, quick charging? Usually this kind of chargers, they use USB 3, USB-C, and we took a look at that, and essentially, okay, the USB-C has more plus for the power, but they share the same ground. So we are still able to measure the electric consumption. And for a dash charge is even easier because you can get your battery charged very fast. And so the current will start to drop down earlier. So if you charge it during the night, we are able to charge even more information. Okay, thank you for the question. Any other question? If there is not any other question, oh, I was so fast. Okay. If there is not any other question, I want to thank you all. And if you want to discuss offline, I will be here. Thank you.